Continuing on with three more examples. They're going to be a little bit more interesting. And what we have here is we have a log equal to a number with an algebraic expression and component in there. So there's many different strategies that we need to think about. And got to always remember, what we do to one side, we really need to do to the other side, or that equal sign becomes invalid. So one of the rules that we have is the inverse properties. And if I can use the inverse properties to maybe get rid of that right there, that would be way cool. And that's exactly what I'm going to do. I'm going to raise everything to the fourth power. I'm going to use a log base 4 of 5x minus 1 is equal to 4 raised to the third power. So I just raised them both to the fourth power. Using that inverse property, I'm going to cancel that out, and then I have that is equal to the thing. But if you think about it, we're just raising this to the third power and setting this equal to that. That's all we're doing. Okay? So this cancels out, so I actually have 5x minus 1 is equal to 4 cubed, which is nothing more than a fancy way of writing the number 64. So I have 5x minus 1 is equal to 64. Add 1, and of course we get x is equal to 13. Right? So not too bad. It looks scary at first, but when we did this strategy using our inverse, it worked out pretty well. So what's going on here? Well, this plus sign is a big indicator. If you remember our product property of logs, we can rewrite this as a product of these two terms right here. So we have log, we're on the same base. So 8x times x minus 20, oh, there goes my writing pad, don't do this to me, is equal to 3. And, well, what can we do here? I could raise them both to the 10th power again. Exactly what I did. I could go log 8x minus 20 is equal to 10 to the third. Basically, remember, this is log base 10, so 10 to the third is equal to that. All right, so I just converted it to exponent is all I did. Well, with that, that cancels out right there, the 10 to the log base 10, so I have 8x minus, that's an x right there. Okay, so I have 8x times x minus 20 is equal to, looks like it's going to be some big old number, 1,000. Right? Distribute, so I got 8x squared minus 20. No, sorry, that is not a 20. Is a 8 times 2 is 1,660. Gosh, turn my brain on. All right. I'm going to go ahead and subtract the 1,000 because I have a quadratic, and I'm going to set that equal to 0. I'm going to divide everything by 8. Works out pretty well that way. I could have done that earlier, actually. That's what I started to do. And I got 20x, and that goes into it 125 times. All right. So when you factor, you think what times what is equal to negative 125. When added together gives you negative 20. And you're going to get 25 and 5, right? I could split the middle, but since the leading coefficient is 1, I'm just going to go ahead and do x minus 25. Bigger number gets that sign. And the smaller number gets the other sign. All right? So that leaves us with x is equal to 25, x is equal to negative 5, but we have a massive problem in here because this guy right here, if I put in negative 5 right here, you cannot have log of negative 40. That would be a no-no. So this is an extraneous solution. All right? It does not work in our problem. So this is our correct answer. Next one. All right? So what do we got going on here? Well, we have something very similar again. We're going to use that product property. And if this is a minus, we can use our division property, so on. So we're log base 4. So that gives me an opportunity to combine these. Okay, so log base 4. And I'm going to have x. I'm going to put the x first because I can. I'm just a left to right person. Blame it on the Indian Hittites. All right, and we're going to have equal to 3. Next step, I'm going to go ahead and raise everything to the fourth power. So basically, if I raise that to the fourth power and raise that to the fourth power, I'll just rewrite it for you. Log 4. So you see the inverse relationship right there. I'm going to go ahead and distribute. So I'm going to have x squared plus 12x, okay, is equal to, that's just a fancy way of writing 64. Okay. That cancels, so I have x squared plus 12x. I'm going to subtract the 64 is equal to 0. And maybe this thing could be factored. Yes, it can be. What times what is equal to negative 64? When added together gives you a positive 12. It's going to be 16 and 4. And the bigger number gets the sign, so we're going to have x plus 16. X minus 4 is equal to 0. Therefore, x is equal to negative 16. X is equal to a positive 4. This is an extraneous solution. So that one goes bye-bye. And we have x is equal to 4. Alrighty, so I'm going to go ahead and get this posted and go on to the next one.